Alrighty. Okay, so last time we were, I think, making some real progress. Just to check back in with our progress here. Um, we finally did the, creating a Tox instance, setting the name and status, that kind of interaction. So the next thing here is friend request, which requires actually connecting to the, or, interacting with the distributed hash table, bootstrapping, that kind of business, I believe. And then on the binary side, we had created, I think, hopefully, the Android binary, but we weren't able to access it from inside the Android application running on the emulator. Um, and I think it's because we did not properly declare assets. And so our next step was to define our, that's an important part of this. It's not the bindings, it's the actual, see, I have this third party folder with a bin, right, that has these two binaries, and I think that's where we kind of lost foot there. So let's check adding, let's see, native assets to Flutter. Okay, all right, let's check this out. Okay, code and assets, sometimes called resources. An asset is a file that is bundled or deployed with your app and accessible at runtime. Right. So for some reason, I think Linux, whenever we ran the app there, it was able to see this entire folder system, this entire file system, right? And so it was still able to find the binary when I searched for it via path from the code. But when we were on the Android application, I think there's a lot more bundling bundling and packaging that's going on. And since it wasn't a declared asset, it wasn't available to us. So I think we need to do this the proper way, which is good. This is another thing to learn. Okay, yeah. So common types of assets: static data, configuration files, images. Oh, maybe maybe this isn't the right place because this is just talking about like images and like data. So is assets not supposed to be code? Or maybe not. Okay, hold on. Let's see if, or maybe there's different types of assets. Let's see. Flutter asset types. I just want to make sure we don't get off on the wrong foot because this is talking mostly about like static data, file types. It does need to be accessible at runtime, but I don't want to. Let's see. Flutter asset types. Oh, okay. When we were looking at FFI and interoperability, so Flutter, FFI, C, interop. When we were looking at that page earlier, does it recommend where to put this? C library. Library path. Current path. Hello library. FFI. Native code is located and its symbol is visible to Dart. Okay, right here. Here we are. Compiling packages and loading Android native code within a Flutter app or plugin. And bind them using the Dart FFI library. Create a C function that implements through a Dart plugin named native add. exposes it through a Dart plugin. Interesting. Okay, native library can be linked to an app either dynamically or statically. Separate file or folder within the app, loaded on demand. One for each architecture. A dynamically linked library. Only dynamic libraries, that's okay. Will native add do the following? Flutter create platforms, Android, iOS, Mac OS, Windows, Linux, template, plugin, FFI, native add. You can now exclude platforms you don't want to build to. However, you need to include the platform of every device you're testing on. Create a plugin with C, C++ resources in native add source. These sources are built by the native build files in the various OS build folders. The FFI library can only bind against C symbols. Attributes to indicate symbols are referenced from Dart to prevent the linker from discarding symbols linked. Okay. Generated links to code, native add Android build. Okay. You might need to update the Android manifest file of the app or plugin if indicated by documentation. Native code and support for the native code toolchain. Add the AAR artifact as a dependency. Don't include the artifact in your Flutter package. Instead, it should be downloaded from a repository such as JCenter. Flutter APKs. I think I got a little bit lost in the sauce here. Hold on. Flutter mobile and desktop applications. Terms for native. Okay. Before your library or program can use the FFI library to bind to native code, you must ensure that the native code is loaded and its symbol visible to Dart, Android native code within a Flutter plugin or app. Bundle C, C++ sources in a Flutter plugin and bind to them using the Dart FFI library on both Android and iOS. In this walkthrough, you'll create a C function. Okay. This is just saying you need to use dynamic linking. Create an FFI plugin. Okay, so this is Flutter create template plugin FFI native add CD native add. So this is they're creating a plugin instead of an actual. I think a plugin is just a project that you're referencing from another project. Okay, maybe it's not, but this looks very similar to how we created our application, our Flutter application, right? With the platforms, this whole business. Okay, then they go into native add /source. They created a source file and they added this. Really bind against symbols, default on Android, the native add. Android build.gradle links the code. Yeah. Okay, so this is the one line that keeps catching me. Updating the Android manifest file or in the app to link against a platform library. Oh, but we're not really doing that. Ay, ay, ay. Distribute the... Here we go. To create a Flutter plugin that includes Dart source code, but distribute the C++ library in binary form, use the following instructions. Open Gradle, add the AAR artifact as a dependency. Don't include the artifact in your Flutter package. Instead, it should be downloaded from a repository such as JCenter. Ay, ay, ay. So they're saying that like I shouldn't have these binaries in my source code. Instead, I should be uploading them to like some repository where the application will download at runtime, which makes sense, right? If I wanted to update TokTok core, I wouldn't want to have to then push a manual update on my app with, or compile this source code again, update it, and then push it. Like that's all this workaround, right? Instead, it would be good if my application was just pulling from some place. I don't know that that is going to work for the POC though. Okay. I think these are the two that I just looked at. Okay, Flutter, let's see. Android app, let's say using C. Using, it can be more dynamically linked library. Let's see. For Dart, with this API, you'll write a simple app. This is a plugin. Import the C library source code into your Flutter plugin. Customize the plugin to allow it to build on all of these. Build an application that uses the plugin for JavaScript. Okay. Let's see. This is an interesting. I don't know what Code Labs is. Okay. Just want to see how they handle. Okay, Doctor. Generating their template. Duct tape. Linux. You need to make a change. The Gradle KTS, use the appropriate NDK person. Make sure you have an Android device. Connect. Gen app. Example, Flutter run. Native function through FFI. Oh, this is the entire FFI. Okay, so they're not actually running it. Ay. FFI gen app. It's template plugin FFI. It's the plugin FFI template. The build files for building and bundling native library with the code. This is interesting. So you could wrap the actual FFI portion of the code into a plugin. This configuration invokes the native build for the various target platforms and bundles the binaries in the Flutter applications using these FFI plugins. Dart plugin class. Oh. Now this is interesting, right? So it's saying instead of having an application that uses FFI, you just create the plugin that uses FFI and abstract away all of the native code into just this plugin. Okay, I think I discovered this earlier, but this makes more sense now that I'm this far into the POC. Maybe I didn't fully understand it earlier, but it's the value of the POC. Okay, implement some other plugin, platforms, some platform. A plugin can have both FFI and method channels. The native build systems invoked by FFI plugins are for Android Gradle, which invokes the Android NDK for native builds. For iOS and macOS, Xcode using CocoaPods. For Linux and Windows, CMake, binding to native code. To use the native code, bindings in Dart are needed. To avoid writing these by hand, they are generated from the header file using FFI-gen. Okay, this part I understand. Invoking native code. Very short running native functions can be directly invoked from any isolate. For example, see sum in libhello.dart. Longer running functions should be invoked on a helper isolate to avoid dropping frames in Flutter applications. For example, see sum async. Adding documentation. When you publish a package, API documentation is automatically generated and published to pub.dev. If you wish to generate API documentation locally on your development machine, use the following command. Change directory to the location of your package, my package. Tell the documentation tool where the Flutter SDK is located. Dart doc. Licenses to the license file. Poorly organized license file. Publishing your package. Pub publish dry run. Handling package inner dependencies. You can now import using Flutter apps or any other Dart project. But if hello happens to be a plugin package, code needs to access platform-specific APIs exposed by the URL launcher. You also need to add suitable dependency declarations in your platform-specific build. You can now import IO Flutter plugins, URL launcher plugin. Okay, iOS. When the following example sets a dependency for URL launcher. Okay. Whoa. Again, a bit lost in the sauce there, but I think I'm a bit off course here, right? Like, I guess I'm still just trying to figure out how I can include my my binary at runtime. Maybe for the next POC, it makes more sense to turn this into a plugin that dynamically builds all of these, and like somehow it looks like somehow in an FFI plugin you can document the full tool chain to compile your native code. Which makes sense. I mean, it's like this perfect level of encapsulation that keeps itself up to date in a, that's not what this POC is, though. I mean, it would have been a better POC, but wouldn't have known about it unless I got this deep in, right? So, all right, let's see here. What types of assets do we have? Is there a way to include compiled code as an asset? Are these all the assets? No, painting library classes. Asset image, package, asset image, Dart. Oh, is there like a generic asset class? asset bundle, asset manifest, asset metadata, asset bundle image provider, asset name, asset image, and asset bundle. Collection of resources used by the application. The asset bundle. Just images and strings that can be used by the application. Access to these resources is asynchronous, so they can be transparently loaded over a network from the local file system without blocking an application's user interface. Applications have a root bundle. Okay, assets. Flutter, okay, asset, and then I can just include individual assets. All right, let's try this out. I wonder if in my pubspec.yaml I just have to define name dependencies, Flutter. There we go, Flutter. Oh, look at this. Assets. Okay, let's add an asset section. This one here. And let's say we're going to add in, what was the name of this? Copy relative path. And let's do the same thing for this one. Okay, let's see if adding it as an asset covers this. First, we need the emulator to run. This is still open, which is cool. There we go, emulator's up. And now we had the Flutter run, I think. That is so far back, can't get to it. Okay, Flutter run it was emulator 5554. Let's keep this out. Okay, let's wait till it comes up, run it again, see if this correctly picks out, if this makes our asset visible, I guess, because it'll be bundled into the application now. I wonder if I have to install anything for assets, or if this is like native enough to Flutter that I don't have to like add in a plugin for assets. Hopefully they're just visible. Emulator still starting up. Wait, this is the Flutter. This is an Android, right? So maybe it's already on. Let's see if it automatically updates. Okay, it's gonna have to package everything. Okay, while this goes, let me keep reading about those native tool chains. The FFI plugin app seems so interesting. The example directory. A plugin is meant to be included in other projects, but you will flesh out the code in the example directory to verify what your plugin. So there's no lib direct. Oh no, there is a lib directory. FFIGen.dart, FFIGen app bindings generated.dart. Interesting. And then source. And I could put the entire TokTok code just right in here. It's cool. And then how does it build? I think that's what's interesting to me, because here it doesn't show that they have any source code that comes in. Okay. Now, what do they actually do here? Hold on, sorry. Build, let's go to Linux first. Okay, verify that you're using a supported version of Linux. Once you've installed all prerequisites listed in step 2, run the following commands in a terminal. Run Linux. Building Linux application. Does that invoke the toolchain itself? That's so cool. Because really it's just invoking CMake. CMake's finding the toolchain you have. For Android, you just have an NDK version. Android emulator, confirm Flutter is able to run. Run. Which device you want to run it on. And it just does it? I guess if you have a source directory, you don't need to add it as an asset. We should try creating this plugin. Ooh, we should do this and see if it works. My guess is that the native compilation of most of these just won't work, but that's okay. And then I'm guessing that the actual what is in this FFI Gen app? Because here I have to link to a very specific, or maybe it already links directly to source. But like there's this intermediary step where I'm pre-compiling, right? And then, creating a native library based on the dynamic library that I pre-compiled. And that's not, that can't be what's going on in this application. Is there like a GitHub for this plugin FFI? Flutter template. I just want to see the source code for this and see how they're doing that. Is there a source code? Studio project. Rust FFI plugin. Ooh, the starting point for this Rust FFI plugin is FFI plugin. Does it show branch off of that? No. Darn. It's not a branch off of that, right? FFI plugin. Here we go. Darn it. Integrate with multiple platforms, Flutter plugins. Integrate with each platform. Okay, this is fun. I'm just wondering where that developing packages and plugins. FFI. I get that I could just create a new project and run this to see what the insides look like, but I think it'd be cool if I could just check out what I'm grabbing on GitHub somewhere. Okay. Flutter plugin. There's no code link to this. Ay. Plugin FFI to call C APIs. Is there does he link to all of it somewhere? Everybody's linking to the same documentation. Ay. Okay, let's see if he just posts enough about it. Okay. Native add IML files content. Build. YAML. entry points, include directives, source files, native add.h, lib files. Oh, cool. Okay. This is native add bindings generated. Dart FFI, native add binding, simple name, library lookup, sum. Native function. Native add.dart. Lib name native add. Dynamic library. Whoa, okay, this is a trove of information. Alright. Definitely gotta try that. No excuse not to try that out. Okay, did this work? No, lost connection to the device. What does that even mean? It's an emulator. There is no connection. Alright, let's, can I go back home? Oh man, maybe my device is frozen. Can we turn it off? If we power it off and then power it back. Oh my gosh, was it not powered on this whole time? What is that? Okay. Okay, now if we do overview, let's close this application. There we go. This is our Flutter app. Okay, now let's run. No wonder it couldn't connect to the device. The device was off. All right, now we'll open it back up. We'll let it run. We'll connect. Same error? Same error. Interesting. See, just putting an asset is clearly not enough for it to be visible. What is my exact error? I get failed to load dynamic library. Okay. Let's see. Flutter, Android, asset not visible. Okay, Flutter image assets not showing up in Android build. This works fine when I run on IDE, making Android APK images in improper declaration of referencing the asset. Following steps outline common solutions. Is in a designated assets folder within the root of your project. Assets. Locate the Flutter section, add the assets subsection. You can declare individual files or entire directories. Insensitive to white space. Terminal to ensure changes are applied and dependencies are updated. Oh, I didn't realize I had to do Flutter pub get. Interesting. Okay, so I did make a change. Let's try Flutter pub get. And now let's run again. Let's open up the emulator. Same deal. Yeah, so maybe loading a binary as, okay, let's see. Consider platform-specific issues. Android manifest. Okay, so this points back to the Android manifest deal. Let's see. Where is the Android manifest? App, source, main, Android manifest. Here we go. Okay, let's see. Flutter, Android asset. Not in Android manifest. Okay, Android manifest.xml. What's going on here? If an asset is not, and you suspect it's related to an Android build process, the issue is likely rooted in incorrect asset. Okay, gotcha. Understood. Old build artifacts can cause issues. File permissions. Okay. So gifts. I'm looking for look. Asset image. Uses permission Android name Android permission internet. Uses permission access network state. Interesting. Loading of assets for web app or Windows app works even if you don't include assets in path, but it won't work for Android. Example, chapters. This won't work for Android. Root bundle.loadString. Use assets as prefix. Okay, I don't think this is necessarily my issue because I think I am using the prefix. Let's check. Yeah, I'm using the prefix third party, which is where I put my code. I don't understand why I'd need the internet for this. Maybe it's because the Android application is loading this dependency or this asset later on. I think declaring it as an image asset is wrong. Uses permission. We could try adding these. Inside the manifest tag. I don't know. Let's check somewhere else. Let's be a little more thorough here. Okay. The asset manifest.json. JSON. Okay, Flutter Android app build. Android emulation, but on web it's working. If you specify the exact image in the it is working. Getting the image is just fine on the web version. Unable to load asset. What does asset say? Okay, maybe not here. JSON. Da, 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 da. Image.asset. I wonder if I just can't treat this executable code as an asset. Okay. Flutter Android. Let's try it like this. Cannot find dynamic library. Whoa. Native shared object is not being located or loaded correctly. Dynamic libraries for Android need to be placed within the Android app source main JNI libs directory, organized by architecture. Holy cow. Is that true? Ah. Dependencies. Woo. Okay. New. Dynamic library with debug in release mode, actual results, main activity, release mode, doctor output, I don't see the cache. I don't see the cache. Okay, sorry. Okay, thanks for providing complete sample code, release mode. I don't know if I'm in release or debug mode. I don't even know that much. Okay, let's hold off on this. I'm not sure where this answer is coming from, but it seems simple enough to be worth a try. This JNI libs. So Android app source main. Let's see, there is no JNI libs. Java, Kotlin, and resources. So I don't know if I should just add it to resources. That seems wrong. That folder isn't there already. And if it's not there, okay. Another question is, why isn't the Flutter pub spec YAML adding it to that? Or why isn't Flutter finding it and then dealing with that, right? So, libraries in your Flutter project. Let's see. Whoop. Shared object libraries contain compiled code that can be loaded and linked dynamically at runtime. The procedure for creating .so libs and using them in a Flutter project is described as so. Create a JNI folder in the project's root and place the .c and .h files inside. The native application.mk. Used in an Android app. Build the native library. Okay, so we're again, this is defining it all inside. Terminal. Build script. Look at that. Android app source main JNI libs. Call the function from Dart and run the app. All right, JNI libs. Let's try it. We've got two sources. We've got an independent source saying that there should be another folder in here called JNI libs. And that this should go, just in the main folder. Nope. That was correct. Move. And then inside JNI libs, I'm just going to copy and move it. I don't want to see. And then, where are we here? And then let's copy this relative path. Drop this in the it's not declared as an asset. Android app source main JNI libs. Maybe starting from main? I don't know how we'd reference that. This seems a little all over the place. Let's do a hot reload. 1 of 739 libraries. I don't think a hot reload is going to be enough. Let's do a hot restart. All right, what do we get? Still can't find. Okay, so it is looking up the correct library now, but it can't find it. What happens if we change to just source? Then we can try main after this. We can try them all. Let's see. That did not work. Maybe lowercase r to reload. No. Wait. Hot restart didn't do this. Let's close our app and then reopen it. Oh. Let's connection to our device. Debug. Not sure why that failed. Extracted path. Execution failed for tax app. Merged debug native libs. Out extracted path. JNI libs. Wait. Is not an ABI. I think our connections are all out of whack here. There's too many wrappers. There's too many pipelines. I wonder if this is just a downside of building apps for like, a single application is supposed to run on all these platforms, is that there are so many different pipelines to getting from source code to whatever your target system that you're running on is, right? Which is, something I was unsure about coming into this POC. All right, so let me think about this critically before we move on. Clearly, the path that I took for the Linux platform is not the is a way that works quickly and ran quickly, but I'm not getting that same success on Android. I can't make those same shortcuts, I guess. There's a bit more to it. And I think I'm starting to see the benefits of one, I was talking in the last release about having a Docker container that compiles all of your images for you, and you kind of, define these containers to build your images, which I took completely from the CI tools on the TokTok Foundation and how bTox was doing it, right? And that seemed like a very smart way to abstract out the actual compilation of the C code for future TokScore updates. I think Flutter and FFI kind of have this own formation of you can define your tool chains directly in your Flutter application and then build them at compile time and have a different tool chain for each architecture, which is amazing, but also seems very, very complicated. I think, I think that idea, though, for a Flutter application makes the most sense, to have those tool chains built in. That way they can be built at runtime. Now, I see that's another thing. I don't know if it's possible to define those tool chains well enough and what kind of limitations come with supporting Flutter, right? Because I don't know that the way that I've been doing it, right, where for each application I figure out how to compile cToxCore and then, just put those pre-compiled code, dynamic libraries directly into the application and ship it, while not preferred from a Flutter standpoint, allows me to reuse the compilation tool chains and procedures that are already documented by cToxCore. Right? It's kind of like TokScore has their way of compiling all of these files, and Flutter provides a way of compiling all these files, and it would require a whole POC to see if I could actually perform that integration. The route I took here is to just use what TokScore said, and then use FFI to just grab those libraries interact with those libraries at runtime. But I mean, obviously, my POC is running into some hardships there too. That kind of integration is not straightforward. Yeah, but I think it is worth it, right? So, I mean, I think it makes sense to use the Flutter paths, and then if they really don't work, the changes should come from Flutter or TokScore to make those work instead of my application. See, the way I've done this, I've made my application this middleman that can, do all this kind of spaghetti nonsense or all this extra business. And I think that that may have been better for a POC, or arguably, I guess, since I'm kind of stuck here. But I think it makes it harder for a real application. I think if I was making a real application, I would want to do the FFI plugin and abstract away all of this nonsense outside the app. That way my app, basically, like, my POC had these two kind of directions, this Dart application that's actually interacting with TokScore library and building out the Tox client, and then this creating the binaries to run. But I think all of this should actually be, instead of me creating the binaries, me finding a way to codify the tool chains and procedures to create these binaries into an FFI plugin. And then the Dart application simply consumes that plugin. Like, these should be two separate projects. They really shouldn't be one project. Interesting. Yeah, I almost wonder if I've like, I'm hitting a wall in all that I'm going to learn from this POC to a certain extent. I mean, I definitely think I could continue to learn about the different compilation pipelines for each of these platforms for CTOX core. I mean, just trying to get the code compiled in each platform would be a large part of this, which is interesting and is good, but I wonder if I should be doing that from within the FFI plugin, from within those build scripts. And then also, to state the obvious, I still don't have access to like Mac OS or iOS for actually testing those out, right? So I'm not sure that I'm ever going to be able to, whatever I compile there, I won't be able to test, which is the whole point of the compilations, right? Or the whole point of the POC, to make sure that those compilations work. So I think we need to redefine the goals of this POC. Not this, right? But I think we need to figure out a better direction to go from here. I think I have no doubt in my mind that I could continue to play with this and eventually get some compilation to run on Android. But I think, here's the real wall, right? I'm not sure that this libtox4j that I compiled using a Docker file that someone from the TokTok Foundation, put up on a repo for another project, right? I mean, this was made actually for the Kotlin bindings, to generate Kotlin bindings for a native Android application, or not a native Android, but an Android application built using Android Studio. And then this Flutter application using the pubspec.yaml to link it as an asset of some sort to get it into the Android packaging system, right? It's like we kind of have this interesting situation from the Android side of trying to include this compilation, and then I have this predefined system from Flutter. This is kind of a microcosm of a much larger issue with the integration of these two frameworks. I think I think ultimately, right, this is a wall we're hitting in the first attempt on the POC, and it makes me want to redesign a new POC that uses the correct formatting, because that's what the real device would use. I mean, we got some great success on Linux, so I do think that this is possible, and it's possible to continue pushing with this POC in weirder and weirder ways. But I think it would take longer than using everything I've gained so far in the POC. I mean, I've spent a decent bit of time on this, right? And I feel like we've learned a lot of lessons. I wonder if I can use those as the groundwork for another POC in the future for how this integration might look and how it might be better. Yeah, that actually makes more sense to me, right? We should use what we've learned here for building a better app. And see, I don't think bTox has done this. Let's actually check and see if they did this or not, right? Man, I said that I would rely on them more in this. Let's find that bTox. What? No. Tox core. What? Okay. CTOX core. Okay, let's see if we can find bTox on here. bTox. I just search that up. Here we go. Official mobile Tox client. Let's see. Do they use an FFI plugin? Work in progress. Dev, get started. Tools, prepare web. Hold on. Let's look at their pubspec.yaml. None, SDK, Flutter, crypto pods. Look at all these dependencies. Okay. There's FFI. River, image, HTTP. Sodium libs. Whoa. Dev dependency analyzer. FFI gen, Flutter launcher icons, generate assets, fonts, and images, FFI generated TokTok score, FFI Dart, entry points, compiler ops, and then inside lib. Do they have any C in this at all, or any .so files in this at all? Dart, C++, 8.6%. Where is that? Linux runner main CC. Okay, I don't know if they actually made that. Let's see, inside app, Android, app, source, do they have that JNI libs file? They do. Feet, add TokTok score FFI. Resources. Foreground, access fine, process text, background. Main, okay, see, it's not in there. I think the question is there a, oh, okay, let's go into their actual Dart code and see how they'd handle it. API TokTok score. Tox.dart. Function name, tox, no spam, bootstrap, iterate. Tox event start, models crypto. Here they're just simply declaring functions. Pack, widgets, platforms, pages, FFI, toxlibrary.dart, JS interrupt, FFI Dart. Whoa, look at that. Return TokTok library, malloc, TokTok FFI, any platform.instance.is Android. So if it's Android, we do libtocscore.so, else we do dynamic library.process. What is libtocscore.so? Is there a single SO file in here? No. They've got a toolchain built inside this file to do this. That's what's happening here. They have a toolchain. They must, right? I don't know if it's even declared in the pubspec YAML. True. Flutter. See, I don't see a TokTok score SO file anywhere, but they're definitely, I mean, we saw it clear as day there, right? They're getting it. FFI generated TokTok score FFI Dart. That's what we're exporting. Import generated. Where is FFI generated? Woo. With native lib, tox new, options. Look at this. toxcore.dart. Scoped. Bootstrap. Iterate. Spam. Name. Set status message. Where is their compiled C library? Does it ever say what the lib is passed in? The tox library is passed in. To each method, or into the creation. So is there a prepare tox score? Windows DLLs yet. They don't support Windows because they don't have the DLLs yet. Okay. Currently from the Linux build. TokScore Linux x86. Okay, Linux. There we go. Mac OS and iOS. Android. Architecture lib. tar components. TokTok releases, download nightly. TokTok nightly Android. Look at that. It's genius. It is genius. They're not doing their own build, and they are doing their own build. Okay. So, that's interesting. Okay, so I was just saying how this POC is running into issues because TokScore has its own way of building on each platform, their own kind of pipelines for doing that, and Flutter kind of has their own way of defining tool chains to build on each platform at compile time, and they're not the same, and the integration is difficult. I go to and I just said like 10 minutes ago that if I had to restart this POC now, or if I do restart this POC, I would take the Flutter approach of trying to get each of those tool chains to work. And here we see in bTox, they did the opposite. They have these nightly builds from TokScore for each platform. And what they do Xcode framework, Android. They have nightly builds from TokScore available on GitHub, and they just download that release. They're not relying, it's just a download. It's just a download, and then they unwrap lib, macOS, tokscore.so, lib tokscore.so. Look at that. At the end of the day, lib tokscore.so. And then they find the SO file like that. Boom. The only thing they don't have are the DLLs from Windows yet, because those aren't part of the nightly build. Genius. Generate FFI bindings. They do prepare TokScore. Generate FFI bindings. It's not equals to Windows. They run the FFI gen. Generated TokScore js.dart. Generated TokScore FFI.dart. This generates those files, and then they pull. Man, that's cool. That's so cool. All right. I need to take a break. I need to think about where this project goes from here. I don't know if I really want to stick to this. This is not Uh, um, this is not a situation where you want to keep playing if your time isn't worth it, right? Certainly not on a proof of concept. I have this long list of projects to get to. I don't want to keep throwing time down here, but this is good. I feel like I've learned a lot. I wonder if I can create a summary of everything we learned and then maybe change what these goals and remainings are and see if we can position ourselves better to do. Yeah, see where we go from here. What's really learned from this POC? I feel like I have learned a decent amount though, just from looking at the other projects and as far as we got on Linux. Um, all right. I'm gonna leave this video here. Thank you.